In this video, we will understand how we can solve the linear programming problem using the Big M method. The question is, solve the following linear programming problem by Big M method. Here minimize z is equal to 5x1 plus 3x2 subject to the constraints 2x1 plus 4x2 less than or equal to 12, 2x1 plus 2x2 is equal to 10, 5x1 plus 2x2 greater than or equal to 10, and x1, x2 is greater than or equal to 0. Now here our first step will be to introduce the slack variables, surplus variables and artificial variables. First of all, as you can see here, the equality constant is given. So there we'll have to introduce artificial variable. That is, for this equality constant, we'll add a1, and for this greater than equal to constraint, we'll introduce the surplus variable as well as the artificial variable. That is, it will be minus s plus a2. And for this less than equal to constraint, we'll introduce the slack variable. That is, here this will be plus s1, and for greater than or equal to, it will be minus s2. So here our initial basic feasible solution will be obtained by x1 is equal to x2 is equal to s2, which will be equal to 0. And firstly, let's write this. Minimize z is equal to 5x1 plus 3x2 subject to the constants, which is 2x1 plus 4x2 plus s1 is equal to 12. Then for equal to, we will add a1. So it will be 2x1 plus 2x2 plus a1 is equal to 10. And for this third constant, which is greater than equal to, we'll subtract s2 and add a2. So it will be minus s2 plus a2 is equal to 10. Now all these we'll have to write in the objective function like this. 5x1 plus 3x2 plus 0s1 plus 0s2 plus this will be this is the Big M method. So it will be ma1 plus ma2. That is, the coefficient of a1 and a2 will be m. And as this is a minimization problem, so m will be greater than 0. Now we'll just write this initial basic feasible solution, which is x1 equal to x2 equal to s2 equal to 0. Now s1, we'll compare it with the right hand side coefficients. That is, here s1 will be 12, a1 will be 10, and this a2 will be 10. And now when we put all these values in our objective function, that is x1 0, x2 0, s1 is 12, and which is a1 and a2, which is 10, 10, right? So we'll get it z is equal to 10m plus 10m, which is 20m. Minimize z is equal to 20m. Now our first step will be to make a table like this, which is CB, basic variable, solution, x1, x2, s1, s2, a1 and a2. This is how we'll make our table. Now let's write the basic variables. Over here our basic variables are s1, a1 and a2. And this coefficients of those basic variables that we have to write from the objective function. So here in the objective function, the coefficient of s1 is 0, of a1 is m, and a2 is also m. So it will be 0, m, m. Now in the solution, which is the right hand side of the constraints, that is 12, 10, 10. Then after, we'll write the coefficients of x1, x2, s1, s2, a1, a2 from all the constant equations. We have 3 constant equations. From those, we'll write this. Like the third one is 5x1 plus 2x2 minus s2 plus a2 is equal to 10, which will be 5, 2, 0, minus 1, 0, 1. Then after our next step will be Cj, Zj and Cj minus Zj. Now this Cj, which is the coefficients that we write from the objective function. So it will be 5, 3, 0, 0, m, m. And Zj, that is, we'll have to multiply this. Cb into x1, that is 0 into 2 plus m into 2 plus m into 5. So for the first column, it is found like this. Then for the second column, same way. 0 into 4 plus m into 2 plus m into 2. Likewise for all the columns. Then we'll subtract this, so we'll get the Cj minus Zj values. Now here, as this is a minimization problem, our entering variable will be the largest negative value and our leaving variable will be the smallest positive ratio. So firstly we'll have to find the largest negative value, but here it is written as m. So we'll have to take some value for m. You can do this in your rough work. Like suppose I am taking m as 2. Then 5 minus 7 into 2 and 3 minus 4 into 2. So obviously we'll get the most negative value for 5 minus 7m. So that will be our entering variable. Now we'll find the ratio. Ratio, which is the solution divided by the values of the first column. That is 12 by 2, then 10 by 2, then 10 by 5. Now from here, the smallest positive value will be 2. So our entering variable is x1 and our leaving variable is a2. And my pivot element will be 5. Now again we'll make a table like this. This will be our iteration 1. Here, as our pivot element is 5, so we'll have to perform a row operation and make that element as 1. And then after, the elements above this, that will make it as 0. Now firstly let's write the basic variables. So the basic variable s1 and a1 will remain the same and a2 will change to x1. And the coefficient of s1 and a1 are same, and x1, the coefficient is 5. And in solution, this we have already found 10 by 5, which is 2, so we can write that 2. And now we'll have to divide the whole row by 5. Why? Because here we need to get 1. So I have written this R3 into 1 by 5. That is, the whole row is divided by 5. Now we'll just find this. Then after our next step will be to make this 2 and this 2 also as 0. So we'll do that 2 minus 2 is 0, which means we'll perform the row operation R2 minus 2 R3 and R1 minus 2 R3. This R3, which is the new R3. That is, I'll just write in rough 10, 2, 2, 0, 0, 1 minus 2 into the elements of the third row, which is 2, 1, 2 by 5, 0, minus 1 by 5 and 0. You can also perform the row operations using calculator. So now on solving this, we'll get the values as 6, 0, 6 by 5, 0, 2 by 5 and 1. And same way for the first row, you can write that in rough or you can use a calculator for performing the row operation. So it is 12, 2, 4, 1, 0, 0 minus 2, then 1, then 2 by 5, 0, minus 1 by 5 and 0. One thing you might have observed that here I have written up till A1. Why? Because A2 is our leaving variable, so that we won't write again in this table. So it will be x1, x2, s1, s2 and a1. We'll keep it till there only. Now we'll find cj, zj and cj minus zj. Cj will be the same and zj, which is found like 0 into 0 plus m into 0 plus 5 into 1. So it's 5, 6m by 5 plus 2, 0, 2m by 5 minus 1 and m. And now cj minus zj will find. Again we'll have to suppose a value for m. So here suppose I'm taking m as 1. Then I get this as minus 1 by 5. And if I put in this, then I'm getting 3 by 5. So my negative value will be 1 minus 6m by 5. That is, our entering variable will be x2. Now we'll find the ratio, which is 8 upon 16 by 5, which will be 5 by 2. Then 6 upon 6 by 5, which is 5. And 2 upon 2 by 5 is 5. So our smallest positive value is 5 by 2. Hence entering variable will be x2, leaving variable is s1 and the key element will be 16 by 5. I'll just circle this. Now we'll work on our iteration number 2. Here again the rules remain the same, that the pivot element you will make it as 1. And in this table we'll include s1 because we don't exclude s1, s2. We just exclude the artificial variables. Right? So it will be x1, x2, s1, s2 and a1. Now let's write the basic variables. Instead of s1 we'll write it as x2 and the other two variables will remain the same, which is a1 and x1. Now we saw that the coefficient of x2 is 3. Then for a1 it will be m and x1 is 5. And in the solution over here you can write this, which is 5 by 2. Our first row operation will be r1 into 5 by 16. Why? Because it is 16 by 5, so we'll multiply it by 5 by 16 so that we get there 1. So the whole row I have multiplied it with 5 by 16. So we get 5 by 2, 0, 1, 5 by 16, 1 by 8 and 0. Now our second row operation will be r2 minus 6 by 5 r1. Because it is 6 by 5. So 6 by 5 minus 6 by 5 will become 0. So on performing the row operation we get 3, 0, 0, minus 3 by 8, 1 by 4 and 1. And our third row operation, which is here we are having 2 by 5. So 2 by 5 minus 2 by 5 is equal to 0. So we'll get r3 minus 2 by 5 r1. And on solving this we'll get 1, 1, 0, minus 1 by 8, minus 1 by 4 and 0. Now we'll write the Cj, Zj and Cj minus Zj. Cj remains the same. Zj will find it, which is 3 into 0 plus 0 into m plus 5 into 1. Same way for the others. Now Cj minus Zj. And again after this, to find the entering variable, we'll have to suppose some values for m. Like over here, if I take m as 1, then it will be 3 by 8 minus 5 by 16, which is coming as 1 by 16. And here if I keep 1, then it will come as 5 by 8. So both are coming positive. So we'll have to try another value. Now I'm trying it for 4. So 3 into 4 by 8 minus 5 by 16 comes out to be 19 by 16. And 7 by 8 minus 4 by 4, it comes out to be minus 1 by 8. So this will be our entering variable. Then after we'll find the ratio, that is this column of solution divided by the column of S2, which is 5 by 2 upon 1 by 8, 3 upon 1 by 4, 1 upon minus 1 by 4. So we get the smallest positive ratio as 12. So our leaving variable will be A1 and 1 by 4 will be our key element. I'll just write it over here. Entering variable is S2, leaving variable is A1 and key element is 1 by 4. Now I'll perform our iteration 3. Same way, we'll make the key element as 1. That is, to make it as 1, we'll have to multiply the whole row with 4. And now over here, we'll write this as x1, x2, s1 and s2. We won't write a1 because that's our leaving variable. And the basic variable will be x2, s2 and x1. That is, in place of a1, we have written as s2. And the coefficient of s2 is 0. Then from solution, this 12 we can write it. And our row operation will be R2 into 4. So this comes out to be 12, 0, 0 minus 3 by 2, 1. Now as you can see over here, we have 1 by 8. We have to make it to 0. So we'll perform a row operation like this. R1 minus 1 by 8 into R2. And another operation we'll perform is minus 1 by 4. We have to make it to 0. So that row operation will be R3 minus 1 by 4 into R1. That is, we write it as R3 plus 1 by 4 into R1. On performing these row operations, in the first row we get the values as 1, 0, 1, 1 by 2 and 0. And in the last row we get the values as 4, 1, 0, minus 1 by 2, 0. Now I'll write the Cj values. Which is 5, 3, 0, 0. And Zj will be 3 into 0 plus 0 into 0 plus 5 into 1. Likewise for the other columns. Then Cj minus Zj. So these are our basic variables, and for the basic variables, as you can observe, we have got Cj minus Zj greater than or equal to 0. So now we'll not perform any more iterations, as we have already reached our optimal solution. So we'll write that the optimal solution is arrived at. From here we'll write the values. These are the values for x2, s2 and x1. So we'll write that over here. x1 is 4, x2 is 1 and s2 is 12. Now we'll find the minimized z, which is 5x1 plus 3x2. So it comes out to be 5 into 4 plus 3 into 1, which is 23. So this is how we can solve the linear programming problem by Big M method. To download my handwritten notes, you can visit my website. I'll also provide the link in description. Thank you.